Hey, welcome back to the academic powerhouse with your mathematical meathead himself, the realist guy in the room. Bada bing, bada boom. How you doing? How you doing? So, guys, where did we leave off? We left off on talking about statistics. On our last video, we brought forth the idea of a high-level introduction to statistics. Statistics, as I said, is all about the ability to tell a story. And in the world of statistics, the stories that are told are stories of truth. Truth. Now, there's all sorts of stories in the world, all sorts of stories throughout the history of human civilization. There are a few key elements that all stories share, especially good ones here, right? Let's talk about a couple of those elements and see the parallels to the story of statistics. And I'll write the word statistics here so it's very clear. Anyway, so the three key elements of all great stories. Here's the first one: characters, conflict, and resolution. Characters, conflict, and resolution. There's so many examples all throughout media, all throughout even our personal lives, in which we can identify each of these elements. Each of these elements. Let's look at a couple examples here, and then, like I said, draw the parallels to the elements that make up a statistical story. So, I have a few stories that you may or may not be familiar with here. I've got Toy Story. Everybody knows the story of Toy Story by now, right, guys? We've got we've got a few characters. We've got Woody, we've got Buzz. Okay, we've got so many different characters, a cast of characters, in fact. And the key conflict in this story is that Woody, our cowboy friend here, believes he is being replaced with the introduction of the new toy Buzz. And so, out of fear of being replaced, out of fear that Andy, the human, will no longer love Woody, he decides to get rid of Buzz, throws him out the window. Um, and they develop a friendship over time, and that friendship leads to the eventual both of them getting together, or both of them kind of getting lost and going on this journey, and then coming back to Andy to realize, wait a minute, he likes both of them equally. He loves both of those toys equally, right? Good story, classic story. Big media franchise resulted from that simple story. Over here, got one of my personal favorite stories in media, the story of Dragon Ball Z. Oh yeah, and if you guys are familiar with that at all, you'll know what I'm talking about. But here, this guy here in the shirt, we've got Goku. And then this white purple thing over here, the alien known as Frieza. Oh, and boy, what characters these are. What characters these are. So, give you a sense. Now, you may not be familiar with this franchise, but I use the word franchise because the story that has been told through this franchise has resulted in a franchise, a $1 billion franchise, multi-billion dollars, and it's because they have the key elements of characters, conflict, and resolution. The characters, Goku and Frieza. The conflict is that after Goku's friends on Earth, a few of them dying, in the world of Dragon Ball Z, there are these things called magical Dragon Balls, these crystal orb-like balls that once all collected will allow the collector to make a wish. A dragon will appear and will grant any sort of wish that there is. There used to be Dragon Balls on Earth, but no longer. So, they go to the planet Namek, a faraway alien planet Namek, in search of that planet's Dragon Balls to revive their fallen friends from a previous battle. Now, with that said, this alien Frieza comes about, and he too has uncovered or discovered or become aware of the idea of Dragon Balls and their wish granting ability, and he is a tyrant in the universe. He wants ultimate power. He feels that if he is able to wish for immortality, that he can then rule the universe much more greatly than he had up to that point in time. So he too goes to the planet Namek, and of course, you have two different parties wanting the same different thing. The other one can't, they both can't have the same thing, so of course that naturally results in a conflict. The way that these guys get their conflict resolved is through fighting, and boy, what a fight it was. If you haven't seen it, I highly encourage you to go watch it because it's pretty fantastic. But ultimately they fight, and they fight to the very bitter end, and one emerges as the victor, and one gets to grant or gets their wishes granted. Again, I don't want to spoil too much if you haven't heard of it, but the idea here is that each of these had characters, conflict, and resolution. All elements to all three of these are elements to any great story. Great story. I'll even write that. Great stories. Now, in the world of statistics, there are three elements that make for a statistical story. Not even a great one, just simply a story in general. I'll lay them out here, and you can kind of see the parallels. There are three of them. But it has everything to do with the idea of center, spread, or I'll even call it variability, and then shape. Shape. Let me talk about those here in a second. But these are the three elements of statistical stories. Remember these for you will hear these terms over and over and over again. So, what do I mean by this? Well, let's go back and see some of the stories of see some of the common stories of statistics, and you can see where these terms fit into place here. As we said in the last video, we introduced what these visualizations are. We have a histogram right over here. We've got a couple of dot plots, box and whisker plots, and a few curves here. Now, the center is basically, when you hear that term center, well, let's look at the histogram for a second here. Center means where where all the data seems to amass, or most of the data seems to amass at a certain place in the data set, in the visualization. You can see here the brown bar that leads to a center. There's a center there where all the data or most of the data seems to, go around. The spread, the variability is meant to say that it's not all just brown bar, it's the gray, it's the black, it's all these bars together. All these bars together creates or leaves this idea of there is a spread. It's not all just brown bar. Again, here it's not all just, even though this dot plot here, it's not all just four. There's more than just four. There's not everything's four. There's got some threes, got some fives. Here, same thing. Not all of them are fives. Okay, spread. How tightly spread or how widely spread are things? You can see here the box and whisker, very tight, compact, small boxes giant whiskers. You can see the curves here. This blue one has a very widespread, green, shorter spread, and then orange, almost no spread at all. Everything's almost, not 100%, but almost most things are concentrated in the middle. And then, and then you have shape as being the third element, the shape. A lot of times you will see shapes that look very similar to these curves here, where they look fairly balanced on either side. Now they could be fairly wide like the blue one, they could be fairly skinny and tall like the orange one, but they're fairly balanced. Not all the time, as you can see here with this histogram. It's got a lot of bars. Most of the bars are concentrated on this end here. So the shape here has a it's very skewed in one direction. You have what's called here outliers that give this shape a long tail of data points outside of where most of them happen to be. You can ascertain that same information from the box and whiskers. A whisker is these little lines here. Whiskers are a tail. If I were to convert this box and whisker to look like a histogram, it would look basically like this one, except for it'd be basically flipped or reflected. Instead of the long tail going this way here, it would end up, because what this is, the long tail would be this way, right? So long tail, the whisker is a long tail. All the data points, or most of them, are concentrated here in this little compact area here. So there's a huge skew here on this one. Here you can see the shape looks a little, I don't want to say strange, but it's just here to illustrate that there's multiple different shapes here. So this one here, right, the shape, right, it goes up, goes down, it goes here, goes here. It's got a couple of peaks, it's got a couple of valleys here. Different shapes, guys, different shapes. This shape here, like I was saying, very long tail. Like I was saying with this one, super long tail, little bit of a bump there, and then a tail again. Boom, done. Here, it's all kind of compact here. Here we go. Shape, shape, shape. You can derive the shapes from these. Anyways, so understand that the elements of a good statistical story, or even just any statistical story, is one of center, one of spread, and one of shape. Your data has to fit into that, for it to be a statistical story. Now, again, let me remind you here, statistics is all about being able to tell a story, one of truth, stories of truth, through the collection and analysis and interpretation and presentation of data. Now, again, we're only going to do introductory statistics here in this course, but understand that no matter what, they all follow this same process here, this same process of first collecting data. And so that's what I want to talk about here in this video, is collecting appropriate statistical data. Well, I don't know. Now I've got a few questions here to ask here, and this will help us and me understand if data that we're going to collect is statistical or not. And you may see a pattern emerge, all right? But I don't care if you're simply just got a piece of paper and you're asking a bunch of people on the street corner, if you've got computers doing a lot of the recording of data, they all begin with a question that is launched and initiated such that answers can be made. And if you are to do any statistical sort of calculations from it, it needs to be a statistical sort of question. So let me run through. Actually, before I even run through some of these questions, The key realization and the key understanding of these statistical questions is that whatever the question may be, it has to speak to this idea of the three elements: center, spread, and shape. And most specifically, the questions have to anticipate and introduce and anticipate the idea that answers will vary, answers will spread, answers will be different depending on who is asked. So with that in mind, let's look at a few of these questions to let it sink in, the idea of what is a valid statistical question, what isn't. And when we do have valid statistical questions, we can then begin to collect data that we can then analyze and interpret and then later present. So you may see some questions like this: how old am I? How old am I? Well, I can certainly answer that. I'm not going to, okay? But listen, ask yourself, how old are you? There's only one answer to that question. Variability is the idea that there can be, like I said, multiple answers to that question. So, is this a statistical question? How old are you? No, because there's only one answer. Now, how old are all the students in the class? Okay, now we got something potentially going on here. See, I mean, again, depending on who you ask, some of you are 11 years old in such and such months, some of you are 12 years old on the button, some of you are 12 and 7 months, and so forth. And so there's variation there. So if you were to ask that question and take your sheet of paper and record everyone down as having a certain age, yeah, you're going to get some variation. So yes, this is a statistical question. How old are all the paintings in a museum? Well, in a museum has lots of different paintings. Lots of different paintings from the Renaissance times to modern times to even more ancient times. And so that should give you the intuitive sense there that depending on the particular painting in the museum, it will, uh, there will be some variation to answering that question. On the flip side, how old is the Mona Lisa painting? Well, I mean, it's just one painting. It's one painting, which we know what the age to be is. So is that statistical? Can I get a variable answer from that? No, not really. So no, it's not a statistical question. How many cars are in your driveway, your parents' driveway? Well, I mean, I'm not saying, at certain times of day. I'm simply saying how many are in the driveway at the exact moment I'm asking. Well, you can look outside and see how many there are. There's no variation there. It just is or isn't. So, no. What were the scores of the students on the math tests? Well, you should have an intuitive sense here that not everyone's going to score the same thing. Not everyone's going to score the same grade. Some of you will get A's, B's, C's. So, depending on who you ask, you're going to get a different answer. So yeah, there's variability there. It is a statistical question. I think you're seeing the pattern here, guys. I think you're seeing the pattern potentially. A student asks the guidance counselor, how many clubs and sports are open for me to potentially participate in? Now, granted, there's plenty at the school. There's plenty of sports. You got your basketballs, you got your soccers, you got your all sorts of things, lots of different clubs. There's a lot, right? But that is whatever that number is, it's a number. It is a fixed number at the time that it is being asked. There's no variation. There's either is 10 clubs and 6 sports, or there simply isn't. So there is no variation. There's no other way. The same, different students ask it, different students are going to get the same answer from that counselor. So no, it's not a statistical question. How many words are in this question? You can count them all up. It's going to be the same every time. Therefore, it's not a statistical question. How many TVs are in the homes of all young people in your neighborhood? Granted, there are only a set amount of houses in the neighborhood, but within each house, there's a different answer as to how many TVs there are in the house. Therefore, because of that variability, yeah, it's a statistical question. Are you hungry? Are you hungry? I'm hungry, but it's either a yes or a no sort of a thing here. Uh, so no, there's not a statistical question to be had here. How many minutes do the students in the class spend on homework each night? Oh, well, I would love for this not to be a statistical question. I would love to hear everyone say they spend hours. When the second they get home, they spend every waking minute on their math homework. I know that not to be reality, of course not, guys. You guys love your SpongeBobs and your Pokemons and your Barbies and your all sorts of manner of things here. I know you're not spending all your days and nights on the homeworks, but, well, maybe some of you are, but most of you ain't. But again, that idea that some people are doing a set amount of minutes, some people aren't, introduces variability to the answer to that question. So yes, indeed, it is a statistical question. So you need to understand the difference between statistical questions and non-statistical questions because as you proceed in this class and even in higher level math classes, you will need to collect data, build out visualizations, interpret data, all manner of things. And you can tell right away whether you're able to do so based on the question. So I would say beyond the obvious variability being the pattern or being really the key determinant here, beyond that, the questions really should be applied to an audience that is more than just yourself. So I'll say, if you want to determine what is a statistical question and what isn't, look for keywords that indicate audience. Audience. If the question is I or you, well, it's probably not going to be a statistical question, right? I can only answer things in one way. You can only answer things in one way, whether it's height, shoe size, whatever. But if we were saying, all the students or, you know, everyone or, um, you know, um, high school seniors even, right? More than just the I or the you. Multiple people. Multiple people can answer things in different ways. So that's a little context clue is determining or to get you understanding that, some of the patterns that emerge in these questions. Um, so audience, and then let's see, what other pattern are we seeing in these questions here? Well, I think that's really the big thing. Like, if again, there's going to be variability in the answer, but the audience is going to be, depending on who you ask it to, you're going to get some variation in the answer. So if you want some strategies, here's the strategy for when you dissect these questions and begin to build out your statistical representations and data and all sorts of things like that. So with that said, all I wanted to do in this video was introduce the idea of, most importantly of all, the three elements of statistical stories. Again, do not forget this, for we will talk in much greater detail. Center, spread, or variability, and shape. Each of these three things we will talk about in much more detail. There are actually measurements and calculations to determining center and spread, which when done so will give us a certain shape. So anyways, that's all I wanted to do here. Get that down and then also get you thinking about how to dissect appropriate questions that will lead to statistical analysis and presentation. So with that said, I hope you got a really good pump on today, guys. I hope you burned real good. You burned a lot of mental muscles today. Man, man, oh man, oh man. All right. Anyways, I kind of messed that up. But anyways, uh, have a good day, guys. See you next time.